This is a brief video that will show you the relationship between total, average, and marginal cost curves. Total cost curve first. Total cost curve we can write as total cost C is a function of output and input prices, PL and PK. When we have two variable inputs. Now, with that in mind, let's define the average cost curve. Since average cost is total cost divided by output, the average cost curve, AC, is equal to C of Q, PL, and PK divided by output. Marginal cost is defined as the change in total cost per unit change in output, holding everything else constant, which makes it the partial derivative of the total cost curve with respect to output, which is going to be a function of output, input prices as well. Now, what's the relationship between the marginal and average cost curves? Let's write average cost, as we did above there, as C over Q. What's the relationship between marginal cost and average cost? In order to examine that question, we find out where the minimum or maximum points on the average cost curve are. And we do that by taking the derivative of average cost with respect to output and setting that equal to 0. So the derivative of average cost with respect to output will be the derivative of this function with respect to output. That's Q times the derivative of cost with respect to output minus C times the derivative of Q with respect to Q, all divided by Q squared. So, for example, the question might be, what's true when average cost is minimized? Q times marginal cost minus C, and this of course is 1, equal to 0, and of course we have the squared term in the denominator. Multiplying both sides by Q squared, a positive number, we see that Q times marginal cost is equal to C, so that marginal cost is equal to C over Q, which is to say, when average cost is minimized, when the derivative of average cost with respect to output is set equal to 0, marginal cost and average cost are equal to each other. And similarly, when average cost is falling, which is to say the derivative of average cost with respect to output is less than 0, then we'll have Q times marginal cost minus total cost less than 0, which implies that marginal cost is less than average cost. So when the average cost curve is declining, we can show an average cost curve up here. Here's output, dollars per unit of output. The average cost and when average cost was declining, when the derivative of the average cost curve was negative, we see that marginal cost is less than average cost there. And you can carry out the third possibility yourself. If average cost is rising when the slope of the average cost curve is positive, then marginal cost must be greater than average cost. These are tautologies, really, just logical outcomes of the relationship between marginal and average cost that you really have to obey and make a reality when you draw your various marginal and average cost curves to answer questions in the course.